Good afternoon, everyone. My name is Nicholas, and this is my honest project, ePlay, e-waste repurposing into educational toys for kids and makers. E-waste is one of the biggest challenges in our digital age. In 2016, 45 million tons of electronic waste were generated worldwide. To put that in scale, this is equivalent in weight to all commercial aircraft we've ever built throughout history. And that's just 1 year's worth of e-waste. The situation is not helped by the fact that only 20% of global e-waste is recycled, and 4% goes to household waste. That leaves 76% that is not clearly documented. In most cases, however, they are incinerated or dumped in landfill. The rapid expansion of technology and the consumption-driven society results in the creation of a very large amount of e-waste in our very households. At ePlay, we challenge ourselves to look at the problem as an opportunity. Our aim is to transform the growing e-waste into electronic and educational toys for kids around the age of 9 and up, in a safe and enjoyable manner. After discussing my project with Dr. Scott Mitchell, who pursued his PhD in hacking and modding, he further enforced the importance of a clear visual language throughout the project, having a strong, consistent aesthetic language to design it in a way it would be packaged up nicely, with a case and a box to make it a whole complete package as one kit. ePlay is a starter kit that comes with the necessary toolkit, a manual, and an open source core device. The toolkit includes an adaptive motor mount, gearbox, and components that allow the kit to plug in into existing toys like Lego. We will expand on those individually. It starts with a simple idea. Motor mounts are manufactured for their specific motor, but how might we design an adaptive motor mount that houses motors of various shapes and sizes? One where the user isn't limited by a motor they had found. We've came up with multiple iterations and prototypes. Ultimately, we found a solution. The design utilizes a clamp design from both sides to ensure salvage motors from a range of sizes could fit into its housing. A dual clamping system means that no matter the shape or size, the motor shaft could always be adjusted to where it's needed, in the middle, aligned with the gearbox. Fundamentally, ePlay provides a DIY framework where users are encouraged to source components from discarded, yet functional electronic parts and attach them to the device. Its primary objective is to inspire local communities by showing the capabilities of repurposing e-waste into functional electronic toys. ePlay provides a low barrier to entry into the hacker and makers community, but it needs to lead to a more detailed engagement. To sustain interest, users are highly encouraged to build upon that low barrier and generate more complicated outcomes as they spend more time with it, sourcing more components from waste, upgrading the toy, creating more function. The constant sourcing of potential material and parts, constant repair and upgrade, creates a whole system of repurposing. I did my own primary research, conducting my own collection of e-waste resource to personally test the validity from all the research and interviews conducted. Going to the recycling facilities in my apartment, with minimal effort, there were so many valuable products I have found within the e-waste bin. Within these appliances, most of them contain valuable functioning components like motors of various types and wireless modules to enable connectivity. However, I used only the small low voltage appliances following the safety guidelines of this project, which were to design the project in line with the mandatory safety standards for children toys, as well as the Australian standard AS/NZS 3760 and 3820 in regards to electrical safety of portable appliances. To validate this project, I've conducted case studies and spoke to industry experts like Will from eCycle Solutions, getting feedback from experienced individuals who are already in practice within this relevant field of e-waste management, hoping to escalate my project into a clearer path with a more feasible outcome. One of the major concerns were regarding safety, electrical safety, choking hazards, and components in themselves could also contain hazardous waste. Andrew, last semester you mentioned about the intrinsic motivation, where the stakeholder would enjoy the whole process, incorporating a narrative or story that makes the activity a quest or journey rather than just the result. Juan also talked about the importance of storytelling and collaboration, and how that might mitigate these problems mentioned. Taking all the feedback and advice over the semester, ultimately, I came up with this, an adventure-style instructional manual. The manual is crucial to this project because it guides the user safely along the way. Through an adventure, the user would follow a journey to complete 4 quests. Each quest builds up the foundation and layers for subsequent quests and educates them along the way until they are ready to assemble a final product safely. The manual for 1 teaches and explains how parts are supposed to function in small appliances, and 2 explains the functionality of common components, what to do when they don't function, and to isolate the problem areas to work out which parts are damaged and should be avoided in use. For example, the function of rheostats is to control the amount of current flowing into an appliance. It would then state that rheostats could be found in a blender with a speed control, and that it could be easily damaged by moisture. So if a product is wet, avoid using the rheostat. The journey or 3rd quest would be a checklist before the stakeholder starts the disassembly process. Simple reminders that could often be overlooked, like switches, has it been switched off? Now this isn't to say it's totally foolproof. The idea is to create a more streamlined user journey where they could refer and follow instructions and understand their product better so they could operate in a much safer manner. All this assembling process should be parental guided, which are clearly stated in the box packaging and at the start of the manual. However, if there are any element of uncertainty, going to the local community workspaces are highly encouraged. Workspaces such as the Brunswick Tool Library, pop-up makerspaces like the Repair Cafe, or Menshed, which would facilitate and guide the kids and makers. ePlay teaches children how to disassemble and identify common components within appliances in a fun and safe manner. ePlay is the bridge that provides the necessary toolkit to get started, a low barrier to entry for children and lesser experienced individuals who want a streamlined gateway into the DIY, hacker and makers community. The whole process is educational and teaches the child through the use of storytelling, visuals, and adventure-style quests. With simple and clear visuals to aid the entire building process, a child could take this and build whatever they want with it. It says to the child, your ideas are really important, because if you had created something and you carried them out, then it's yours. There are 2 main methods which the user could utilize the starter kit. One of which is to build their own frame, using an old CD player or any plastic shell as the chassis, which houses the core device and adaptive motor mount. In my case, I used a 3mm acrylic sheet. The other has an opportunity to retrofit the kit into the existing toys, making it electronic and remote control enabled. With the expiration of LEGO patent on its interconnecting technology, there is an opportunity to create parts to retrofit into the LEGO system. 3D printing components that would allow the user to seamlessly integrate ePlay into the LEGO Technic ecosystem. The possibilities are endless and caters to all genders. At the end of the journey, the child would have newfound skills, knowledge about common components within appliances, and understand how to safely disassemble them. Of course, a new toy. With online communities for support and daily inspiration, there are countless possible outcomes that could be made from e-waste using ePlay. The outcome is only limited by the child's imagination. The social outcome of this research project would provide a platform that creates an environment to stimulate the child's curiosity, to foster exploration and creativity. Through play, this project stimulates their imagination and problem-solving skills. My project not only teaches but also gives an interactive feedback, which is crucial for an effective education. It would also encourage parent-child interactivity and bonding, as there is a degree of complexity to it, from sourcing components to building and playing. This project could aid the process of a cultural shift. From a young age, they would be exposed to knowing e-waste is a massive environmental issue and there could be a solution. Really, there are no fixed rule or ideal outcome as long as the child learns. The outcome really could be any physical toy they had built, or the outcome could be that they take away lifelong skills of sustainability knowledge. Given the opportunity, I would love to expand on more kits. Right now the focus is on the core device and the adaptive motor mount. This project, however, could be expanded to more adaptive design for different waste streams or additional specific e-waste components to make the process even more streamlined. The proposed project does not solve all the problems identified. However, it will materialize and inspire a potential direction, highlighting current issues and provoke discursive thought as a step towards the circular economy we want to see in the future. Iterating this process generates a family of electronic toys. New objects can evolve from obsolete ones. A whole ecosystem of open and repurposed products.